Hello, in this video we will demonstrate several key features of the Application Delivery Intelligence, ADI. Please be aware of this legal disclaimer before viewing the video. By analyzing and visualizing data from different sources, the features of ADI that we will present allow for more rapid identification of areas of an application that are of interest to application developers. In our example, a team of developers is responsible for mobile healthcare application. The application consists of several Kix transactions and was deployed into pre-production for performance test of the recent enhancements. The test team ran load tests and reports that the browse patient information function of the mobile healthcare application now takes almost 10 times as much time compared to the previous milestone. We will demonstrate how to use ADI to help the development team focus on the root cause of the performance problem. We start in ADI with the welcome page, where we can select how we want ADI to group the data from various providers. We select operations, which will make ADI put operations data first in the analysis pages. We navigate directly to the analysis view. On the analysis view, all of the application data is collected from the sources such as static application data from application discovery, a Megamon for Kix, or code coverage for testing. The data is also visualized and analyzed. On the summary page, we already see that the operations data shows that the average response time for the application is high. It's in the red zone of the operations gauge on the top. From the analysis summary, we can quickly check information on all of the providers that are part of this analysis collection. What is more important for our example, we can also drill into the details of the operations data. The detailed view shows transactions with reliability issues. One of the first things that we notice in the table is that transaction HCP1 is exceeding the response time thresholds, and that the average response time for this transaction exceeds 20 seconds. The DB2 wait time is contributing over 70% of that response time. This is definitely an area of concern. We drill to even more details down by clicking on the transaction name in the table. This takes us to the transaction performance charts. Notice that the performance of this transaction changed from acceptable to really bad on August 31st. We click directly in the chart area and check the dialog which shows transaction performance metrics for that particular date. We confirm that transaction response time is over 20 seconds, and almost all of this time is the result of waiting for DB2. We also see that ADI has detected static analysis data that corresponds to this transaction. Right from this dialog, we can go on to display the artifact composition for this transaction. The composition graph shows a blue circle icon on the COBOL program node. This indicates that the program has changed within the last week. The red circle indicates that based on the metrics that ADI analyzed, the program has some risks if it's modified. The graph is filtered on the nodes that access DB2. Recall that DB2 wait time has contributed over 70% to the transaction wait time. This program is definitely something to pay closer attention to, and we click on its node in the graph to explore forward and backward call trace and open the program metrics dialog. In the program metrics, we can see that the program was last updated on August 30th. We can also see that test code coverage for the program is available for August 29th, which means that the August 30th changes potentially were not tested. After examining the program metrics, we can search for the program name to see if it impacts any other parts of the application. To search for the program, we can copy the program name and paste it into the search page. The search results show that the program is used in 8 different transactions. As the result of our analysis, we can determine that this program, which was recently modified, was not properly tested, reads from DB2, and therefore is most likely the root cause of the performance problem reported by the pre-production performance test. In conclusion, we demonstrated that by collecting, trending, analyzing, and visualizing data from operations data provider like Megamon for Kix, static analysis data providers like Application Discovery, and testing data providers like Code Coverage, Application Delivery Intelligence is able to help efficiently identify areas of interest to application developers.